going to work on changing radicals to fractional exponents, and we're going to extract roots. It sounds like something that you would do at a dentist's office, but we're going to do it here, okay? So, actually, I want us to start with, you have a calculator. I want you to do some stuff. I want you to find 25 to the 1/2 power and the square root of 25. 25 to the 1/2 power. 8 to the 1/3 power and the third root, the cube root of 8. To the 1/4 of 4 Go to math. Alright, what's 25 to the 1/2? What's the square root of 25? What's 8 to the 1/3? And what's the cube root of 8? How about 16 to the 1/4? And the 4th root of 16? Yes. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's the 4th root. Yeah. The 4th root. So another way of writing radicals is with fractions. You have like the 18th root of h. You could put h to the 1/18. Right. It would be exactly the same. Exactly the same. Yeah. If you have the 18th root of h to the 5th, what would that equal?
5 out of 18?
Yeah, h to the 5/18. Exactly. That's right, h to the 5/18. Okay? Now, in your book, they give you an algebraic reason behind this, okay? We know it's, you can read yours better, but it says the square root of x equals x to the a. So to get rid of a square root, you square both sides. So you end up with x equals x to the 2a. If the bases are the same, then you can set your exponents equal to each other. So 1 equals 2a and a equals 1/2. So this is the algebraic reason why this right here works out. Okay? This is the algebraic reason why it works out. Now, quick question, why do you have to restrict it? Why does it have to say given that x is greater than or equal to 0? What kind of number do you get if you stick a negative under that radical? Yeah, you get the I. You get imaginary numbers, and we don't want that. Question 2. How do you, we just answered that. Okay, never mind.
What number?
702, but now I'm on 703. Alright, what would be equal, we just talked about this, what would be equal to the cube root of x?
X 1/3.
Alright, what would be equal to the cube root of x squared?
X squared.
Alright, great. We're going to do the chart on number 4. chart, chart, chart on number 4. We're not doing all the chart. We're doing most of the chart. All right, complete the cells in each row. And the last column, write x is greater than or equal to 0, or all real numbers. Describe the restrictions that result in equal terms for each row. So, if you have the fourth root of x squared, what would that be as a fraction?
2
Okay. Now, does that one have any restrictions? Can I put negatives under here? It's a fourth root. Can I put negatives under there?
No.
No, you cannot. So the restriction would be that x has to be greater than or equal to 0. Now this one, they gave us exponential, and we've got to go back to radical. X to the 3/4. Okay? So there's going to be an x right there. 4 on the outside, 3 on the inside. Any restrictions?
Are we doing nothing radical?
No, I don't care too much about the middle row. What would it just looks like this? Okay. It's that. Yeah, you just throw in some things. Makes it too crowded on my chart. Alright, if I have x to the 2/5, what did that look like in the radical? What's the root? 5. What's the exponent? Does that one have any restrictions? Can I put negatives inside of an odd power? Yeah, I can have negatives inside of an odd power.
X is less than 0.
It should be all real numbers, because I can put in negatives or positives. You can put in positives or negatives. That R with an extra leg on it, that means all real numbers. Alright, what would this one look like? Fifth root of x. What would that look like as a fraction? Right? Any restrictions? Nope.
So the bottom number is odd number. What if it's just a whole number? And it's all like
You can put anything you want. We're just talking radicals here.
okay.
You can rewrite a radical expression, like the nth root of x to the a, as an exponential expression, x to the a over n, for all real values if n is odd, and for all real values greater than or equal to 0 if it's even. This right here, super important. Super important. Super important, okay? Alright, we're going to go back to just notes for a minute. Because what we need to do now is pick up some stuff that a lot of people have forgotten since Algebra 1. Okay, so remember for radicals, on numbers, we try to get a prime factorization, and then you have to have repeated factors for that root. So if we're trying to get a cube root, in order to get something out of a radical, you need 3 of the same number repeated. If it was like, heaven forbid, if it was like a 21st root, you would need 21 of the same number repeating before you could take it out of the radical. Okay? Let's hope we never see a problem like that ever in our entire life. But whatever the root is, when it's a number, whatever the root is, you have to have that many numbers repeating before you can take it out. Okay, for example, let's say we have the fourth root of 32. How many factors have to repeat before we can bring them out? 4. 4 factors have to repeat because it is fourth root. Okay, so what goes into 32? 2 and 16. Okay, see these four right here? Now, do I get to take 4 2's out? No, it takes 4 of them going in together just to get one little guy out, okay? So I get 1, 2 out. And see this poor little fella right here? Sad Sam? He's sad and lonely. He has to stay inside. Yeah, right there. That's how we are going to reduce the number, okay?
If it's hard, it only lets you use a certain number.
Oh,
It made me mad.
that was
That might make it so
confusing.
down.
I can't see it. Alright, so you can still, you're still gonna have 4. Oh, look at that. It's like a mouth of like a little mustache. Anyway, you still have your 4 with your 1 left inside.
I have a question.
Yes.
What are you gonna do with the 16?
I see it.
Nothing, because I kept breaking them down. The only thing that, this is the work. This is the, what you need to work with. Okay? Yeah. Alright, let's try another one.
32. 7. 86. 99.
Third root of 162. Alright, I have no idea what goes into 162, except I know one number that does. 2. And how do I know that 2 does?
Because it's
Because
even.
it's even. Yes. 2 goes 81 times. Oh, I'm very familiar with 81. 9 times 9.
3 times 3. 3 times 3.
Alright. So how many factors do I need to repeat? So I've got 3 3's right there. So I know 1 3 is going to come out.
1 3 is other 3 is 1 wins 2.
This 3 and this 2.
The 6.
So it's going to be 6 inside. Yes.
All of them are
Very good.
I'm an idiot.
What was left over?
3 and 2.
A 3 and a 2. Remember the very first 2 that we did?
Cube root out of one root.
Yeah, it's a cube.
I'm very good at this.
Yeah.
Part of me gave up on me and just let me pass through.
Is one root a word?
You know.
No.
Because I just automatically forward, one.
Yeah. If you want to say it, then we'll say yes. You can invent that.
What else?
What? Fourth root.
Okay. Fine.
Okay. I'm going to give you 2 to do on your own. No, right now. And then we're going to do variables. We haven't enough variables yet. Alright, so 18, what'd you break it down to? 9 and 2?
3 and 3 and 9. And then you go for 2 3s, 2's left us, and 3 4.
Yes. Awesome. What about 135?
5 and 27. 27 we broke into 9 and 3s, and 9 and 2.
Okay, so
Up there, and then you put 3 square root of 5.
not square root,
No, the
cube root.
Oh, cube root. So you good. Yep.
If there's not a number if there's not an index right there, it's a square root.
But if there is, you start
If there is, you use whatever it is and keep it the whole time. Alright, now let's talk variables. Alright, let's say we have the third root of m to the 7th.
Wait,
What? Go back to here? What? What number?
is it 3 just stay there?
This one? Yeah, it was there, so it goes there. Yes. Okay. The third root of m to the 7th. I'm looking for a third root, so I still need 3 repeating to come out. Okay? I'm gonna show you why it works, and then I'm gonna show you like a super easy thing to do. So I have 7 M's. 1, 2, 3. 7. Okay. Here are 3 right there. So 1 M gets to come out for those 3, right? Yeah? So that's 1 M. Here's another set right here. So another M gets to come out for that right there. And then that little fella right there, he doesn't get to come out, right? I know. Sad Sam doesn't get to come out. So it's M times M. So this would be M squared times the cube root of M, right? Okay? That's great. What if this had been M to the 52nd power?
You do not want to do that.
You don't want to write that out, right?
No.
Okay. So, yeah, you would just divide by 3. And the setup is your root, your exponent, and your answer is your outer exponent. Your remainder is your inner exponent. Okay? You might want to write this down. We're going to do, I said 52nd power, right? Okay, so we're going to
50
do,
seconds. I can't remember.
first of all, let's do it with this one, the easy one. The exponent goes in, and the root goes out. 3 goes into 7 how many times? 2, with 1 left over. Look, outer exponent, inner exponent. Way easier when you have like M to the 52nd than drawing out 52 M's and putting them in groups of 3. Okay, so let me show you. You have this written. You have that written. Okay. Let's say we've got the cube root of M to the 52nd power. What's going to go right here? What's going to go right here? And 3 goes into 52. With 1 left over. So that's going to be M to what power? 17. This is your outer exponent times the cube root of M. You could put M to the first if you really want to, but it doesn't change.
Where'd you get
53 times 17 is 51. You have to be able to do long division. You can't put this in your calculator because your calculator is going to give you a decimal. And you're not going to know what your remainder is. So you have to remember how to divide from like 3rd and 4th grade. Good luck. Okay, so let's try another one. Now that you know the basics. Warming up. Really going to throw a hard one at you.
That's hard. Oh, God.
Mmm. Just do one at a time.
Yeah, that's what
What's 16 divided by 4? There aren't even any remainders on this one. 32 divided by 4? That's your answer.
What?
Oh, when you did
Y'all were all
the
scared.
fourth root, you bring that out?
16 divided by 4 is 4.
I mean, like, with the answer, when you bring the fourth root.
No, there's nothing left inside. There was no remainder. Nothing was left inside. What?
Let's say it was M3.
Like this?
Like M3 to M32. Square.
A square or a fourth?
Four. There we go, 4.
Okay.
How would you do it?
Well, that sad little M's got nothing.
So,
Because see, even if I can still use my division. How many times is 423? 0. Nothing comes out.
we just leave it in?
It stays in. So you'd have n to the 8 times the 4th root of m to the 3rd.
Okay.
You might as well go third.
Generally, we put them in alphabetical order. Yeah. it can't be first. It's inside the box. It can't come out.
Put it behind it.
So say
No, no, no.
say you had like O or whatever, it'd be in then O and then
Yep. Okay. So you survived that one.
Barely.
Try that one.
Well, actually,
All right, let's look at this. So just deal with the X first.
Maybe
3,
take two of them on.
so 2 come out
And then
and 1 stays in. So when I get to write it, it's going to look something like this, right? What about the Y?
2 and the remainder 2.
2 with a remainder 2, so it would be Y squared cube root Y squared.
Oh, I wrote X and Y as an
Now let's put that together, okay?
X squared, Y squared.
X squared, Y squared.
Squared. X, Y
Exactly.
Well, I basically got
Exactly. Alright?
So do we have to do that at the bottom, or can we just automatically put it on the
You can automatically put all
whenever I
that.
put, would you count wrong if I, in like the first thing, if I put X to 1 and Y to 2?
No. No. Alright, remember yesterday's even, odd rule.
Yes.
Let's talk about that for a second.
Even on, you add absolute value. Check this.
Alright, fourth root of X to the 7th, Y to the 12th.
Take it on the X one.
Okay, so the X is going to be 1, and what's going to be left inside? 3. What about the Y? 3 on the outside, none on the inside. Okay, look. Even, odd.
Absolute.
Yes. Just like that. That's exactly how you do it. That's an even number. That's an even number. That's an odd answer.
It's like an X to 7.
It's an even, odd rule.
I know. They don't have to be
Seven's
like
not
outside.
even.
I know, we just skip that or?
Yeah, because it's not even. Just the one it goes with. That's it. Just the even, odd. That's it.
I know.
Yes.
Alright, so what if the X was the even and the Y was odd? What's still be even and
If this was,
Like,
if this was the 12 and that was the
Yeah.
7, even, odd, and you put that in.
Oh.
Yes.
Okay.
It goes with the variable.
So like
It
treat
follows the
the
variable.
other ones in there.
Right. Because it's each individual. You know how over here I split it up and I did both of these separate? They really are separate. And you just write them together. So you treat them separate. Why didn't we bottom it even, odd on this problem? Yeah, that's odd. Right there. That's odd. You're done. It's an even, odd rule. Okay? Even, odd.
So even if like say 7 on that one you were just on, it was like 3, 7, 8. If that 7 was like a 6, could it go even?
That's not an even number. You don't worry about it.
So if that's not an even number, like it's done.
Even root, even power, odd
Oh,
answer.
okay.
Yeah. Even root, even power, odd answer. Okay? Last one that we're going to do like this, and we're going to look at the book again.
You just like exploded my mind. Like,
Did I? You have to clean up the mess. I'll give some paper towels and some 409.
alright, that's fine.
what is it?
I don't even know what to say. Like, I don't even know what to do. Why didn't you even pull the space?
Alright, just try this one. I'll give you tiny little happy numbers, okay? How about the square root of a squared b to the 5th? Alright, so do that one. Alright, a squared becomes what?
B squared.
It has to have bars, right? Even, odd,
Oh, okay, now I'm
it's
good.
gotta have some bars.
If it's odd, then you do the
Oh,
one's odd. 2 even numbers.
Alright, what about b to the 5th? It's out. What's out? B squared. What's in?
Big three.
Big.
So
Yes.
when you go to the odd, is it the number on the outside of the square root? or
The
whatever?
answer. The answer.
If you wrong, you put it at 2. Not that
It's the same thing.
I know, but I know.
Right here?
No, like on the answer. You put it 2.
Right here?
Oh,
Yeah.
you guys were even? I was like, oh, that's what we have. So,
Alright. Even root. Oh. Even power. Sorry. Even root. Even power. Odd answer. Goes an absolute value. Okay. Even root, even power, odd answer goes an absolute value.
So
Was there a 2 there the whole time?
No, it's
My
a square root. You don't have to. If nothing's there, it's a 2. Right. If someone said, "Is it okay to put a 2 there?" and I said, "Yeah, you can put a 2 there." That helps you out. Okay, go back to the book for just a second. And we're skipping, and we're skipping, and we're skipping to, there we go, right here. I want you to do E,
What page is that?
2 I said like
708. Do question E. Do question E. All right, let's look at this one. Each of these is its own separate problem. I'm working with the square root of 25, the square root of a squared, the square root of b to the 8th, the square root of c to the 10th. Okay? You can tell me the square root of 25. You've been doing that for years now. You know that 5 times 5 is 25, right? So this one, that's 5. What about this one? A. Even, odd. What about this one? B to the 4th. Even. We're cool.
yeah.
Okay. What about this one?
C to the
C to the 5th.
so it's
Yeah. Now, here's the thing. Some people were trying to put it together like this.
I did. But is that wrong?
Well, yeah, that's insane. Like, you can't, it looks like you just imprisoned your numbers. Okay? Break them free. Alright? Let's go ahead and put our non-stuff together, and then let's put our prison stuff together. Let's do that. It's just easier to read. Yes. This is what you want to write right there.
So the
Oh,
ones that
are you taking a
are
picture? I would do it again.
I'll take a picture of the answer.
Sir.
Do it again.
You want to put it on my story or something? Okay, hold on. Okay, we're good.
Okay.
I'm gonna tag you and put. I like a bunch of math.
Okay, good. All right, now the only one I want you to look at is G, the cube root of x plus 3 to the 9th. This one's really easy, but because it's got that x plus 3, everyone's like dying. It's not. It's just x plus 3. Like, how many times does 3 go into 9? That's your answer. Yeah. Everyone has like had a stroke today at this problem. It's super easy. It's probably easier than this one. What? Because it's all of this being taken to that power, the whole thing, and we're just dealing with exponents. Yeah. All right, look at the pages that you tore